So guys, here in this video we will discuss about that how the binomial approximation convert to Poisson distribution. So here we know that the binomial distribution function at a certain point, that p of x is equal to r is equal to, we can write that ncr p to the power r q to the power n minus r with the relation, with the condition p plus q is equal to 1. And this is the binomial distribution, and under the condition that n is finite, where n is the total number of trials, and p be the probability of success, and q is equal to 1 minus p, that is a probability of failure or the complement of the event p. But now the condition is that when the total number of trial is large, that means n tends to infinity, and the probability of the success, that is p, is tends to 0, in such a way that m is equal to np. M is equal to np, and here this m is a finite number. M is a finite number. And when this condition is arise, that is the total number of trial is infinite and the probability of success, that is p, tends to 0 in such a way that m is equal to np, then we will use the Poisson distribution. And the Poisson distribution is of the form, that is p of x is equal to r is equal to e to the power minus m into m to the power r by factorial. And here we will now calculate that how can we find from the binomial approximation convert to the Poisson distribution. So this is the condition when we use the Poisson distribution, that is the total number of trial is large, or we can say that n tends to infinity and the probability of success is greater than 0. And here as well as also there are two outcomes, that is for the binomial that distribution there are two outcomes and every outcomes are independent. Similarly for the Poisson distribution there are two outcomes, either failure or success or win or loss, and here every trial is independent. This is the main point. There is every trial is independent. And now I am going to show you that how can we find the Poisson distribution function by using the binomial approximation. So see here in the new slide, here I am just showing you that suppose that is for a point p of x is equal to r is equal to, we can write ncr p to the power r q to the power n minus r. And under, if we consider the following conditions, that is n tends to infinity, p tends to 0, such that m is equal to np, where m is a finite number, then from here we can say that ncr into m by n whole to the power r, and q means 1 minus p, that means 1 minus m by n whole to the power r. That is here, from here we will get P is equal to m by n, and we know that P plus Q is equal to 1. So Q is equal to 1 by P. So we put here 1 minus P whole to the power n minus R. That is 1 minus m by n whole to the power n minus R. So now we have to calculate it. So now see that NCR means we can write n factorial divided by n minus r factorial by factorial r into, we can write m to the power r by n to the power r into 1 minus m by n whole to the power n minus r. We are not changing it here. Okay. So now see that from here, can we write this is n into n minus 1 into n minus 2 dot dot n minus r minus 1 into n minus r factorial divided by n minus r factorial into r factorial into m to the power r by n to the power r into, we can write 1 by m by n whole to the power n into 1 minus m by n whole to the power minus n. So now this one and this one is cancelled out. So from here we can write n into n minus 1, n minus 2 dot dot n minus r plus 1 divided by r factorial into m to the power r by n to the power r into 1 minus m by n whole to the power n into 1 minus m by n whole to the power minus n. So now from here, how can we calculate? See that from here, we can write it n into n minus 1, n minus 2 dot dot n minus r plus 1 divided by n to the power r into m to the power r by factorial r into, see here now, I'm just going to calculate this portion. Okay. So see here that as n tends to infinity here, so from here can we say that limit n tends to infinity 1 minus m by n whole to the power minus r is equal to 1 as limit n tends to infinity 1 by n is equal to 0. So we get this one is 1, and we know that from the properties of limit, the limit n tends to infinity 1 minus m by n whole to the power n is equal to e to the power minus m. These are the for the properties of limit. So now from here we can write it by easily that e to the power minus m. So now from here, and see that here n minus 1, n minus 2 into n minus r plus 1. That means we can, and see here that there are, that is n minus 0 into n minus 1, n minus 2 dot dot n minus r minus 1 divided by n to the power r into m to the power r by factorial r e to the power minus n. So now here that you can see that here are r. So now can we write from here, that is n by n into n minus 1 by n into n minus 2 by n and n minus r minus 1 divided by n into e to the power minus n into m to the power r by factorial r. So from here, that you can see that here now I'm going to the new slide. That is what we get, that is n by n into n minus 1 by n into n minus 2 by n dot dot n minus r minus 1 by n into e to the power minus m into m to the power r by factorial r. Factorial r. So from here we can write 1 into 1 minus 1 by n, 1 into 1 minus 2 by n into 1 minus r minus 1 by n into e to the power minus m into m to the power r by factorial and as n tends to infinity, whereas 1 by n tends to 0, we can say that these all are 1 into 1 into 1. So from here we will get e to the power minus m into m to the power r by factorial r. Here you use the factorial sign by either r or r factorial. Both are correct. So here as I use in the first r factorial sign by like this, r factorial. So here you can also use this sign, r factorial. So from here we can write that is e to the power minus m into m to the power r by r factorial. So this is the derivation that how we can say that it is now changed from binomial to Poisson approximation. And I hope you understand that how can we find the binomial, that how we can change the binomial approximation to Poisson distribution. So thank you for watching the video.